Okay, so we're going to look at rules about means and variances, and for some reason I don't have the correct file here. So I'm just going to do this on a blank set of slides, but I will put up the problem so you can follow along with the problem. I'll go and find the PDF and post it. So we're doing rules for variance and standard deviation. All right. So I'm just going to read the problem here. And then you can tell make sure that you have the correct worksheet. But it's Josh's insurance company offers a death and disability plan, pays $10,000 if you die, $5,000 if you're disabled. It charges a premium of $50 per year. Suppose that the death rate in any year is 1 out of 1,000, and that another 2 out of 1,000 suffer some kind of disability. So I guess that means that 997 people out of 1,000 are going to stay healthy according to this model. So let's make a table that displays the probability model for the insurance policy. Leave room for an extra column or two that we'll add later. So first I'm going to make up a random variable. So I'll have my random variable being, I guess I'll make it something about cost or money. So I guess I'll make it cost. So I'm going to make my random variable C, and I'm going to say that that's the amount of money you get from the policy. So there's 3 scenarios here. You're either going to pay money for this policy, or if you become disabled, you get the $5,000, and if you're unfortunate and you die, your beneficiary gets the $10,000. So I need to put all of that into a table with the corresponding probabilities. So there's a 1 out of, did I say 10,000? 1 out of 1,000 chance that a person dies, and they're going to get $10,000, but they paid $50 for the policy, so they're only going to get $9,950. So I'm subtracting out the $50 that they paid for the policy. So then there's a 2 out of 1,000 chance that the person is disabled. They get the $5,000, but again, they paid the $50 premium for the year, so I'm going to subtract that out. So they would get $4,950. And then if the person stays healthy, which is a high probability, 997 out of 1,000, then they're not going to get any money from the company. So I'm going to make the value for C be negative 50 here, because you actually paid the $50 and you're not going to get that money back if you stay healthy. So notice this problem is a little bit trickier than the ones that we were looking at in the previous video, because we have to take into account how much money we're paying and how much money we're getting back for the various scenarios. Okay, so now I want to figure out the expected payout, and I also want to figure out the standard deviation for my random variable. So let's figure out the expected payout. So I'll add a new column here to my table. Or actually, you know what? I don't need to add the new column. I'm just going to write out the formula here. So if I want to find the expected payout, that's going to be mu sub c, the mean, the expected value, the average, the weighted average. All those terms are synonymous. They all mean the same thing. It just means I'm going to multiply every c value by the corresponding probability, and I'm going to add all of those up. So that'll be 9,950 times 1 out of 1,000 plus 4,950 times 2 out of 1,000 plus negative 50 times 997 out of 1,000. And that gives me, so if you do the computation out, you get that the expected amount of money that you'll get from the policy is negative $30. Now, this totally makes sense because an insurance company is a business, so they need to be taking more money in than they're giving out. And there's the bell, and we'll pick up back up with this video and talk about standard deviation momentarily. Okay, we're back after the bell here, 24 hours later, but only 1 second should have passed in the video. So now we're going to introduce the concept of standard deviation. So it has kind of a crazy formula, but remember it's just on average, how far are the numbers from the average? And then we're going to introduce the concept of variance, which is just the standard deviation squared. So sigma is the Greek letter, the lowercase sigma, that's what we use for standard deviation, and sigma squared is what we use for the variance. So I'm also going to put a subscript c, because c is what I named my random variable for my expected amount of money that I would be getting from the insurance company. So the formula here is that we're going to take every c value and we're going to subtract the mean. We're going to square that value to keep that positive and multiply that by the corresponding probability. Let me just run through that one more time. So you take every c value, subtract off the mean, square that value, multiply by the corresponding probability. So I'm going to do that for every value of c in the table, and then I'm going to add up all of those. That is the variance, and then I just square root that to get the standard deviation. So let's work through that with our particular example. So I'm going to take every c value, so I had a c value of 9,950. I'm going to subtract the mean, which is negative 30. Square that, and then I'm going to multiply that by the probability that I got the $9,950, which is 1 out of 1,000. So I'm going to do that for every value of c in the table. So I'm going to add that too, and then I'm just going to move on to the next c value. So I've got 4,950 minus that negative 30 squared times the probability of getting that $4,950, which was 2 out of 1,000. Add that too. Last was I get the negative 50, which is I pay my $50 but stay healthy, so I don't get any money from the insurance company. Subtract off that negative 30 squared. Multiply that by the probability of staying healthy and just paying off the $50, which was 997 out of 1,000. So I would do that. This is where graphing or scientific calculators are great. I would type in exactly what I've written down there. I would type that as one line on my calculator, hit enter, and then that would give me the variance in dollars. Now this is probably going to be a massive number because there was a lot of spread here. And I get that it is 149,600. So that is the dollars. That is the variance. Write that down, that's the variance. And if I square root that, I get the standard deviation, which is $386.78. That is the standard deviation. So just one thing to remember is that the variance, the standard deviation carries the same units as the original problem. the variance carries the square of those units. So I guess really technically the variance is 149,600 square dollars, which is kind of awkward and doesn't make sense. Which is why typically the standard deviation is that's the value that I'm going to be most interested in. It has the same dollars as the mean, the same units as the mean, in this case dollars, and it's telling me on average how far my x values, or in this case my cost values, are away from the average.